You sound way more excited than I am. Number one, what is momentum? Martin, tell me what momentum is.
Momentum is inertia in motion.
Yes, I like that definition. The book likes it a lot, uses it all the time.
What's inertia?
So inertia is an object's tendency to resist change. So inertia in motion is basically motion change resistant specifically for moving objects. So this is like throwing a baseball. This is kicking a soccer ball. It's not getting a couch moving. So that's the difference. We're not talking about getting a couch moving necessarily as we are talking about what's happening when the couch is moving already. So inertia in motion. The other thing you could say would be momentum equals mass times velocity, because that is literally the definition. And just as a reminder, P means momentum. Not to be confused with capital P, which means pressure, and not further to be confused with the Greek letter rho, which looks like P, but it actually means density. So super easy not to get confused on this one. The good news is we're not using any of those for this unit. The bad news is we are using all of those this year, including this semester. So it's not a big problem now. It will be important to be careful on when you take the final, okay? Because when you take the final, there will be pressure problems, and there will be density problems, and there will be momentum problems. So it is something worth being careful of. So again, little p is momentum, not to be confused with big P, which looks very similar but is not, which is pressure. Not to be confused with the Greek letter rho, which also looks like a P, but like a curvy P, and that's one's density.
Why would you do that?
I appreciate that you think I came up with all the symbols for physics, but I assure you I did not live 200 years ago. Be sweet, but I did not. Not one of the Marvel Eternals. Or am I? I mean, it's pretty obvious I am. Anyway, so that's momentum. Momentum is inertia in motion, or it is mass times velocity for an object. Good. So what's the unit? So the unit is both easy and hard. So if momentum is equal to mass times velocity, that means it's equal to kilograms, which is our mass unit, times velocity unit, which is meters per second, which means the unit for momentum is kilograms meters per second. That's the unit for momentum, kilograms meters per second. And I've actually written a letter to the organization that officially does units, and I've asked them to change momentum units to Borcherdings, and so far no. It's only a matter of time, though. I think everyone will eventually see the light that Borcherdings just makes sense as a momentum unit. So kilograms meters per second. All right, impulse. Let's see. Scott, let's do back of the room, Scott. Back of the room, Scott. What about impulse? What's that one? Close. Very good. So impulse. You know what? Actually, I'm fine with that. So impulse is force times time interval. Say again?
Change in momentum.
Yes. So force times time interval. You could also say impulse equals change in momentum. More, what I say, impulse is what causes a momentum change, and that's number 4. What's the effect of impulse? The effect of impulse is it causes a momentum change. And this is really what matters, right? This is really what matters. If I just say, hey, the momentum of this dodgeball throwing through the air is 70,000 kilograms meters per second, you'd be like, ooh, that's a number. Nice. But you don't know what that means. Like, I don't even know what that means. If you said it has 7,000 kilograms meters per second, I'm like, great. I can't do anything with that number. It makes no sense. This is what makes sense. Impulse changing momentum. If I told you that the momentum changes by 7,000 kilograms meters per second, now I can do something with that. I can figure out how much force was applied, how quickly did this happen, what happened to the object that got hit by the dodgeball, right? So if I throw the dodgeball at a student's face, not that I have ever done that before, mostly on accident, okay, then I want to figure out what happens when the ball hits them, right? I don't care about what happens to the dodgeball through the air. I care about what happens when it hits the person. Did they fall? Did they catch it? Do they stop where they are? Does it bounce off them? Like insults apparently are supposed to bounce off people and totally do. People never get upset when people insult them. This is the thing that matters, the momentum change. That's what really matters. So this idea of impulse. And that brings us to number 5, which is what is the impulse momentum equation? Okay? The impulse momentum equation is this. F delta t. And by the way, delta t is the symbol I use for time interval. And if you're wondering, Mr. B, why don't you just use t? Like we've used t all the time. Because t is like the fall time. Delta t is the collision time, and they're not the same. The time it takes a skydiver to fall is different than the time it takes a skydiver to stop. Hopefully with a parachute. Okay. So delta t is time interval. So force times time interval, that is impulse. It equals a change in momentum. It's almost like it's the impulse momentum equation. Yeah, see what they, it's Monday, okay, I get it, it's Monday. That's the impulse momentum equation. Okay. Let's do an example problem. We'll take a short break and I'll give you a story time. Okay? Jared, you're going to remind me? Story time about dodgeball. Okay? He's totally going to forget. Remind him when he forgets. Okay? Story time about dodgeball. But we got to do the example first. Okay? Questions on 1 through 5?